In this video lecture, we have talked about Taylor series. For that, consider a function f of z, which is analytic inside a circle C. The value of f of z inside the circle C is satisfying certain series and is called Taylor series. If the function f of z is analytic within a circle C, centered at the point A, then the value of f of z inside the circle C is given by a series called Taylor's series. The series is f of z equal to f of a plus z minus a into f dash of a plus z minus a whole square divided by 2 factorial f2 dash of a plus z minus a whole cube divided by 3 factorial f3 dash of a, and the last term could be z minus a power n divided by n factorial, then f power n of a. To understand this, we should draw a circle C. Say this is a circle C with the center at the point A. Within this circle C, the value of f of z is given by the series called Taylor series. To prove this, construct another circle C1 inside C, which is also having the center at the point A. So we have to adjust the center. This A is common to both C and C1. The point Z should be present inside the circle C1. Let W be any point on the circumference of the circle C1. See, this is the point Z. Now, you can write. To prove this, construct a circle C1 with its center at the point A and assuring that the point Z is inside the circle C1. Let W be a point on the circumference of C1. Now, the value of 1 divided by W minus Z, which is equal to, see here, 1 divided by W minus Z equal to 1 divided by W minus A plus A minus Z. 1 divided by W minus Z equal to 1 divided by W minus A plus A minus Z. Minus A plus A, 0. We can get W minus Z. This is equal to 1 divided by W minus A minus of Z minus A. Just I have written W minus A as such, then by taking this negative sign outside, A minus Z is modified as Z minus A. Now we will modify this further. Say this is equal to 1 divided by W minus A into 1 minus Z minus A, 1 minus Z minus A divided by W minus A. Now 1 divided by W minus Z, which is equal to 1 divided by W minus A into 1 minus Z minus A divided by W minus A entire power minus 1. Now we have to apply our binomial theorem, and then it is simplified as 1 divided by W minus A 1 plus Z minus A divided by W minus A plus Z minus A whole square divided by W minus A whole square plus Z minus A whole cube divided by W minus A whole cube. Then Z minus A power n whole divided by W minus A power n. Now multiply all the terms with the help of this 1 divided by W minus A. This is modified as 1 divided by W minus A plus Z minus A divided by W minus A whole square plus Z minus A whole square divided by W minus A whole cube plus Z minus A whole cube divided by W minus A power 4. And the last term could be Z minus A power n divided by W minus A power n plus 1. N plus 1. Here we have to put 1 divided by w minus z. Now we have to multiply all the terms by f of w and then integrate. Now the first term on the left hand side becomes, this is f of w divided by w minus z into dw. Here f of w divided by w minus a into dw. This is z minus a f of w divided by w minus a whole square into dw. The next term is z minus a whole square f of w divided by w minus a whole cube into dw. The next term is z minus a whole cube integral f of w divided by w minus a whole power 4 into dw. In this way the series is going on. The last term is z minus a power n within the integral f of w divided by w minus a power n plus 1 into dw. It is known to you. Now we have to evaluate the integrals one by one. See the first integral. To evaluate this, we have to use our Cauchy's integral formula. We know the Cauchy's integral formula. That is f of z0 equal to 1 divided by 2 pi I integral f of z divided by z minus z0 into dz. This is our Cauchy's integral formula. From this integral f of z divided by z minus z0 into dz equal to 2 pi I into f of z0. Using our Cauchy's integral formula, we have written the value of f of z divided by z minus z0 dz, that is equal to 2 pi I into f of z0. In this same aspect, you may write the value of f of w divided by w minus z integral f of w divided by w minus z into dw, which is equal to 2 pi I into f of z. See here the subtracting term is z0, so we have written f of z0. Here the subtracting term is z, so 2 pi I into f of z. In the same manner, the value of f of w divided by w minus a into dw within the integral, which is equal to 2 pi I into f of a. The subtracting term is a, so f of a. This is 2 pi I into f of z, which is equal to the first term is 2 pi I into f of a. Now you have to find out the value of f of w, the value of integral f of w divided by w minus a whole square into dw. This value you have to find out. For that, differentiate this with respect to a. d by dA of f of w divided by w minus a into dw, which is equal to 2 pi I d by dA of f of a. Here the variable is 1 divided by w minus a. d by dA of 1 divided by w minus a, which is equal to d by dA of w minus a power minus 1. This is minus 1 into w minus a power minus 2 into minus 1. If you differentiate this w minus a power minus 1, minus 1 comes forward, multiplied by w minus a power minus 2, then differentiation of minus a is minus 1. So this is equal to minus 1 into minus 1 plus 1, that is 1 divided by this w minus a square. Minus 1 into minus 1 plus 1, 1 into w minus a power minus 2 is modified as 1 divided by w minus a whole square. Therefore, this integral d by dA of f of w divided by w minus a into dw is integral f of w divided by w minus a whole square into dw. On the right hand side, 2 pi I f single dash of a. d by dA of f of a is f dash of a. Now the integral f of w divided by w minus a whole square dw is equal to 2 pi I into f dash of a. So write down this z minus a as such. Instead of this integral, we have to put 2 pi I f dash of a. Now come to this third term. We have to find out the value of f of w divided by w minus a whole cube into dw. This value you have to find out, this integral. For that, we have to differentiate this. That is d by dA of integral f of w divided by w minus a whole square dw, which is equal to 2 pi I into d by dA of f single dash of a. Here the variable is w minus a power 2. So d by dA of w minus a power minus 2, which is equal to minus 2 into w minus a into minus 1, here minus 3. This is equal to 2 divided by w minus a cube. Therefore, integral f of w, this value d by dA of integral f of w divided by w minus a whole square into dw is f of w divided by w minus a whole cube. This should multiply by 2 into dw, which is equal to 2 pi I into f2 dash of a. Then f of w series integral f of w divided by w minus a whole cube dw, which is equal to 1 divided by 2 pi I into f2 dash of a. 1 by 2 is 2 factorial. So 1 by 2 is 1 by 2 factorial into 2 pi I f2 dash of a. So instead of this term, we have to write plus this is z minus a whole square 1 by 2 factorial 2 pi I f2 dash of a. This is the value of this term z minus a whole square integral f of w divided by w minus a whole cube into dw. Next we have to find out the value of this term f of w divided by w minus a power 4 dw. For that we have to integrate this term, differentiate, not integrate. Take this term d by dA of integral f of w divided by w minus a whole cube dw, which is equal to 1 by 2 factorial 2 pi I d by dA of f2 dash of a. Now consider the left hand side. We may get d by dA of w minus a power minus 3, which is equal to minus 3 into w minus a power minus 4 into minus 1, that is equal to 3 divided by w minus a power 4. So this integral is modified as 3 into f of w divided by w minus a power 4 into dw, which is equal to 1 divided by 2 factorial 2 pi I d by dA of f2 dash of a is f3 dash of a. Now integral f of w divided by w minus a power 4 dw equal to 1 divided by 2 dot 3. 2 factorial is 2, then this 3 comes here. This is 2 pi I f3 dash of a. Actually 2 dot 3 is our 6. 6 is our 3 factorial. Therefore this is equal to 1 divided by 3 factorial 2 pi I f3 dash of a. So the last term is plus z minus a cube. Instead of that integral, we have to put 1 divided by 3 factorial 2 pi I f3 dash of a. Now we have to cancel 2 pi I on both sides, then we will get the entire series. Say, if you cancel the 2 pi in the left hand side, f of z is the term. Here if you cancel f2 pi I, f of a will be the first term. And plus z minus a, f dash of a. Then plus z minus a whole square divided by 2 factorial f 2 dash of a. The next plus z minus a whole cube divided by 3 factorial into f 3 dash of a, and the series is going on. That's all about our Taylor series.